All right, so some small changes to this. One of the things is I've got the live erosion update working decoupled from the render thread. Some other things, I changed the way the textures are referenced, and now it's got this clamp to edge behavior, but that's not super important. Anyway, so what this is like, I've now got a worker thread that goes and computes the update parallel to the render thread, and so you see this number here separately. I can change the number of particles that run on it to compute that update, and so bringing that down, you get these updates down in like 300 millisecond range, and you start to see where that's changing the speed that's getting loaded at. And you bring it all the way down, and there are less significant updates, and there is some overhead of preparing the textures and things, but I'll explain that in a second. If you put this up here, you start seeing, second and a half updates, but they're, a fair few particles have run between these updates. So if I move around, you can see that it stays responsive even with that many updates being computed. And the total frame time is staying low, down in the 3 to 5 millisecond kind of range. So, kind of neat. This is the way this is done is with, so I've got a small, and this is just for timing here, but it's basically just this thread captures the class scope for the engine, and it loops forever until we're looking to quit. And it's got a flag called erosion ready, which basically means that this so in the main thread I've got so if the erosion map is ready, I send the textures to the GPU and tell it that the erosion textures are now not ready, which gets this behavior going again. So this just loops forever while the program is running on a second thread. And what this does is it does the erosion calculations, which there are much better explanations of that. This is a particle-based hydraulic erosion. But then it also goes through and prepares textures. Where are they at? So these standard vectors of unsigned characters, the height map and the color map, those are created from this height map data that is created by the erosion. So now the only thing that gets called for the main thread is GL buffer textures. Literally, it's where is it? I'll just send to GPU. Yeah, right, exactly. So it's setting up the height map texture and the color map texture, and I can go ahead and show this off. We've got to set up some kind of toggle for this, but basically this is Yeah, right. So it's just text image 2D with that data. So that's all that needs to happen in the main thread. So you don't really see any major difference or hang or anything when that update finishes. So because you're doing it in the second thread, and I'll show the profiling. Well, I guess anyway, you can see one thread is going to be pinned with that update. Okay, and then this is using linear filtering, and I'm honestly not as big a fan of it. I have to change one other thing for this. Because that step size needs to come down, and I don't really have a toggle for that, so I've got to manually change it. Wait, that is actually where it's supposed to be at. Anyway, that's really bad. Anyway, the way this this is the Comanche style rendering, where it's nearest sampling on the texture. The other one is using bilinear filtering, and really only works well on smooth gradients, like for example, I need to change how that works because the update actually forces a anyway, whatever. What this is doing then is computing the update, preparing the textures in that other thread, and then setting them from the main render thread. So the interaction with the OpenGL API is kept to that one main thread, and it prevents any synchronization issues. So this is completely, this simulation update and the amount of time that it takes is completely decoupled from the rendering time. So you can see smooth movement, and also this work is happening in the background. So it's actually working well. Just that one lambda and that to create that thread is all I needed to do. That's the only substantial change to make this work. The coloring right now is just, it's based on, there's a gradient with respect to height from red to green, and then there's part of that preparing textures is actually there's a computed normal. It's part of the erosion thing, and so I'm basically keeping that, translating it a little bit to give me something that looks like a normal for the ground. And then I'm doing some lighting with that and a vector pointing straight up, taking the dot product. So when I have these flat areas pointing up, I'm getting lighter colors. And when I see a slope, I'm getting darker colors. And so you get steeper slopes are darker, and then you get highlights on the flat parts. So, and then that is applied as a scale factor for the coloring, that color gradient. So all comes together pretty well. I need to do something with the filtering on the minimap textures because I really don't like how that strobes like that. But I do have the offset so that the viewer now sits at the back edge, or front edge, however you want to call that, so that it more realistically represents the positioning of your view, right? It kind of gives you a sense of like what's in front of you rather than giving you a big chunk of stuff behind you. Anyway, stuff down here looks like lava, I guess. This logic all still works for the other maps. It's just a matter of when that erosion update thing, I can do this, like put it at 50,000, and then that's going to take several seconds. And then that's not actually that difficult. I can, well, we can wait and see how long it actually takes. It'll be 10 plus seconds. But yeah, then pick some other thing, and that's what it looks like. But then with oh, interesting. It actually hangs even longer because that thread has to join at the end. And the way that that's implemented, well, I'll get to that in a second. So now, when I've got this update like this, we go to 50,000. Okay, and then want to look at one of the other maps. Now, this is using the bilinear interpolation to this is very similar to the way that Outcast did its rendering. Yeah, about 15 seconds on that other thread with that size update. So it looks okay doing it with the bilinear. I'm just not the biggest fan. It requires more steps to get good data or get good sampling when you're going out across the thing. Probably something I'll do real quick tonight is add a toggle and also change the behavior of the update function so that it, I guess, probably just doesn't run if I have any other map selected. It's probably the best way to do that. But anyway, the yeah, this real high frequency variation locally, it doesn't like that. There's a lot of tiny bumps and things. But you can see how it creates these slopes in between what would otherwise be sort of blockier shapes. They become linear slopes rather than being just a step, right? It's now you got these interpolation artifacts. Yeah, that's an interesting element with the shutdown. That's I could probably do something with that, but that's not a super big deal. Anyway, yeah, so that's where